We present GR Control, an exploratory research project aimed at assisting the elderly and those with limited abilities in interacting with the world around them. Through combining diverse input modalities and methods of feedback and control with an integrated software platform, we provide the possibility for simple and seamless control of smart home features such as lights. Motivations. The primary motivation behind the research and development of GR Control is the understanding of the issues which an aging demographic faces. As large segments of the Canadian, U.S., and Japanese population enter old age, physical restrictions related to mobility and sensory deprivation reduce their ability to conveniently and effectively interact with the physical world around them. A large bubble in this demographic will likely put a strain on younger generations seeking to care for the older population. Engaging technologies can facilitate care and the protection of independence, well-being, quality of life, and confidence. The UN and many other global organizations suggest there is a serious technological need to support an aging population. The various types of physical, visual, and auditory impairments experienced by this segment of the population require technological solutions with various methods of input and feedback. To begin, we have developed several capabilities. 1. Inward waving can turn multiple lights off. 2. Activating multiple lights, then adjusting the pitch of the arm to control brightness. 3. Selecting color control with the fist gesture, then adjusting. 4. Selecting individual lights by pointing, confirming with visual feedback. 5. Using multiple hands for interaction. 6. Controlling multiple variables, such as brightness and color, for individual lights. 7. Also, using a smartwatch for interaction. The underlying technology we have used to develop this functionality includes Myo Armband. This device provides gesture capabilities through the use of a gyroscope, accelerometer, and magnetometer, which allow for orientation of the device in 3D space relative to a fixed coordinate system. Unique to the device, electromyographic sensors can record electrical activity produced by muscles in the arm. These EMG sensors detect the contraction of localized muscles, allowing for the classification and recognition of unique gesture sets. The combination of these capabilities make this hardware ideal for exploratory research because we are able to access all raw data for the purposes of development. Smartwatch. The smartwatch is ideal, being commonly used by people of all ages. Given its convenient form factor, market interest, and widespread adoption, we can confidently consider its use and improvement well into the future. Smartwatches commonly include a gyroscope, magnetometer, and accelerometer. Kinect. The Kinect employs an RGB camera and depth sensor, allowing for motion capture and localization of human skeletal components in 3D space. This allows us to infer a pointing gesture, which can produce interactions upon intersecting with predefined objects. By capturing information about the user and the space around the user, we can infer interactions between users and objects. Key concepts. Multiple sensoric data minimizes the unreliability associated with the use of a single sensor. Ability to perform continuous control interactions as opposed to discrete selections. Future ideas. Considering the future of GR Control, we aim to expand gesture capabilities by building and deploying a machine learning classifier. This would allow users to easily create new gesture sets based on personal preferences and abilities. User adoption will demand additional capabilities for interaction with devices such as locks, thermostats, entertainment devices, and many more. Due to the variety of physical, visual, and auditory impairments experienced by aging populations, flexibility and feedback will be a key area of research. Input flexibility will also be of great importance. For example, Incorporating an audio modality will give more degrees of freedom, allowing for a wider variety of input. Primary objectives will be a high level of robustness and the reduction of false alarms. In conclusion, we present GR Control, a gesture-based, multimodality method of input and feedback designed with the elderly in mind. This fusion technique will allow us to provide smooth human-computer interaction in order to control home appliances with minimal cognitive and physical efforts for the completion of a diverse array of everyday tasks.